Let's have a look at the relationship between objects and data. Object-oriented programming is appealing because it captures real-life entities as classes and objects in our code. And so the encoding of the relationships between objects is very natural. In every object, we abstract the data that describes an entity in our problem, as well as the logic or the behavior of the entity. Then, different objects communicate with each other, and we can think about this interaction in the same way as we think about the interaction between real-life entities in our problem domain. Say we have a game where the player has to navigate a maze to get to a prize. The player will be an object, and the maze will be another object with various attributes defining them, like this. Notice how the data is part of the object and how in the behavior of the two objects there is interaction as they are calling each other. For example, if the player wants to take a right turn, the player objects will need to ask the maze object if that location is free in order to perform the move. The different player objects can have different values for their attributes. For example, when players have different avatars, or when the player's life decreases as time goes by, and the player does not succeed in progressing through the maze. Thus, the object is the container for our data, bringing together many types of data sources.